Hi, my name is Dr. Al Cordes. I'll be your instructor for the course, and I made this introductory video to um, try to introduce you to the content of the course and also tell you how the course is going to run. So let's get started. So physics is looking closely at the world around us. One of the nice things about physics is that it deals, for the most part, general physics anyway, with everyday objects. And courses like chemistry, where you have to think about theoretical things like atoms. In physics, you tend to deal with concrete objects. So it's the most basic science, and that's why it's required for if you're serious about studying biology or chemistry or any of the technical courses. Physics is usually one of the fundamental courses that you have to take because it's really at the basis of all sciences. Now, mathematics is the language of physics, so there's always a fair amount of mathematics in a physics course. This one stresses algebra and trigonometry as opposed to calculus, so there's no calculus in this course. But there is an expectation that you have had experience with intermediate algebra and at least right triangle trigonometry. So text and topics for the course. The text that we're going to use is called OpenStax College Physics, and it's what's called an open educational resource. I think it's quite a good text, high quality text, and the authors have released it free. So I have specifically edited it for this course, and I have posted a PDF file of the textbook that's free. And however, if you want a hard copy of the book, you can, when I say hard copy, it's actually a soft cover. But anyway, it's available at the college bookstore or directly from Amazon, and the price is very reasonable. They just printed for the whatever their cost is, and it's roughly $15. So that's worthwhile if you want to have a hard copy of the book. Now, some of the topics in the course, most of the course is we study mechanics, and in mechanics, we study motion, which includes linear motion, circular motion, objects that move around in a circular path like planets, for example, and rotational motion, objects that rotate on their axis, like a bicycle wheel. And then for all of these, we take a look at forces involved and gravity, work, energy, and momentum. Then we also take a look at fluids, and by fluids I mean both liquids and gases, and we study fluid statics and fluid dynamics, and then waves, wave motion, and then the last module deals with sound. And hopefully you'll find this an interesting course, learning all about the world around you. This is a lab course, and so we will be doing labs in the course. And labs involve measurement and experimentation, and it's really an important part of science. And it's also an interesting and fun aspect of the course because you get to see some of the concepts that we have been discussing. Most of the labs will be using a lab kit, and I'll have some information about how you're going to get that. And then there's a couple of labs where we're going to do video analysis, and there's some free software that I'm going to have you download and install on your computer, and you'll be analyzing some videos that I'll provide for you. And that's kind of a fun experience too. There'll be some additional items that you'll need in addition to the lab kits, but this is just things that you can get locally. For example, string and ruler, a plastic ruler with centimeters on it that has a groove on it, and things, a couple of things like that, not very much. You'll be generating graphs, and we'll be using some online software for that, and breaking the ice module. I've got some information about the link for that and how to use it. And then you'll also be doing lab reports, and in the lab reports, of course, you'll be reporting your findings and submitting those to me, and I'll be evaluating those. There are certain skills that will help you out as you do the labs. The first of which is being careful with significant figures. Now, if you haven't had exposure to significant figures, the first module, first thing we do is review those, so you should have a handle on those by the time you do the first lab. Scientific notation is something that you should have had in your math classes. I did provide a link if you needed a bit of a refresher on that. But you'll be using that not only in the labs, but oftentimes in the problems. Probably this is the most important thing. You need to be as patient with the labs as you can. Try to be a perfectionist. Set things up as precisely as you can. Don't rush. Keep careful records. Don't record your measurements on a napkin, for example, or record it sloppily so that you don't understand what it is. Make sure you put the units in there. That's always important. And then follow directions. I try to make the descriptions in the labs as clear as possible, but sometimes things are not as clear as I thought they were. Ask questions. And that not only goes for the labs themselves, but for any part of the course. Please don't ever hesitate to get on and that ask the professor section. That's what it's there for. I'll be checking in on the course just about every day. So if you ask a question, you should have the answer by the next day at the latest. Homeworks and quizzes. All right, we're going to be using an online homework system that's called Expert TA, and this is separate from Moodle. There is a charge for this. I think it's $32.50 that you'll have to pay. But when you log on to it, you will find the homework assignments for each one of the modules. The questions are taken directly from your textbook. I'm the one who picked the questions, so that they're all, I think, reasonable, and you should be able to solve them. They start out pretty straightforward, but then they get a little bit more challenging. One of the nice things about this Expert TA is that there are hints and feedback available. So if you're stuck on a problem and you have no idea how to complete it, you can request a hint, and it'll give you a hint and give you some direction on how to solve it. And if you submit an incorrect answer, of course it tells you it's incorrect, but then it also gives you some feedback based on your answer. It tries to figure out why possibly you went wrong. Okay, and then of course I'll be available for questions as well. That the Expert TA doesn't give you the direction that you need. I'm always available. All right, it pays to spend time on homework. It's very important. Homework is where you apply what you've learned, and sometimes you think you understand something, but when you have to apply it, you find out that you don't understand it as well as you thought. And if you do understand it, it gives you reinforcement and a little bit more confidence. Okay, in addition to the homework, there's going to be one quiz per module. Now, I have here 30 minutes, but it turns out that all the quizzes are going to be 20 minutes, except for one, I think, that's 25. So they're a little bit less than 30 minutes. They're obviously open book quiz. They're multiple choice, but you are not to get any outside help while doing the quiz. So that would include trying to Google an answer or anything like that. You can have your notes available. You can have the book there, but any help that you get should be from within the course. Okay, finally, the last thing is that both the homework and the quizzes need to be completed by the due date. And after the due date, you're going to lose access to it. So if you don't complete the quiz, then that means you get no credit for it, and then the same thing for the homework. Okay, so in addition to the reading and the labs, there are videos and simulations in each module. So the videos first are ones just like you're listening to right now. They're PowerPoint lectures, 2 or 3 that address topics in the reading. They're not meant to be totally comprehensive, which means that you also need to do the reading in the textbook. Every one of those also has PDFs of the PowerPoints that are included directly below the video, so you can download those if you want and take notes on them as you listen to the videos. In addition to the videos, there are 2 or 3 simulations in each module, and I have the instructions there, and the instructions give you a link to the simulation, and it explains in detail exactly what you are to do and the questions that you are to answer regarding the simulations. The instructions themselves are in PDF form, and the questions that you need to answer are to be completed and submitted in Moodle. So there's a quiz section that's not really a quiz, but it's set up as a quiz, and it's in Moodle, and you answer the questions right there. They're all essay-typed questions or free answer questions, and I will be grading those. Some of these simulations can be accessed on a tablet or a phone, those that are written in HTML5, and the particular simulations are called PhET simulations, P-H-E-T, and there's even an app for the Apple. Anyway, I'm not sure if there's an Android app for that, but otherwise you can just do it on your laptop or your desktop. The others, you're going to need to have Java installed, and that's not a big thing usually. Java is already installed, but if it isn't, it'll tell you, and it directs you to a link, and you just install it, and from that point on, the simulations will run fine. Simulations, again, should be fun, interesting. You get to see the physics principles in action, and I taught an online physics class last year, and the simulations were very popular. Okay, so some final words or thoughts. check into the course often, first of all. That's critical to make sure that you're up on the assignment, or if there's any news that having to do with the content of the course. Stay on track. Online classes, it's easy to put things off. Don't do that. You need to have some self-motivation and make sure that you're handing in things in a timely fashion. There's a lot to do, but if you think about it, if you took this course in face-to-face, there would be 6 hours of class time per week, 3 hours of lecture and roughly 3 hours of lab, in addition to, other work that you would have. So there is a lot to do, and it'll take some time, but hopefully you'll find it worthwhile. Do the reading, as I said. Don't just depend on the lectures. There are 2 discussion questions that you'll have to participate in. There's some details there in the course about how those are going to work. Make sure you keep up with the homework and the quizzes. Same thing with the labs. Don't fall behind. Don't wait until the last day to do the labs where you're rushed. Do them well in advance, and make sure that you spend some time with the write-up and the report. The format for that is also in the course that you should, on the course documents that you need to check out. Again, don't fall behind. I know sometimes life gets in the way of these things, but try to keep on top of things, and contact me if there's some issue comes up and you absolutely can't get something done. I'm a pretty reasonable person, and but you need to contact me and let me know if something like that happens. Okay, and then finally, have fun. Not everybody finds physics fun, but I think if you give it a chance and you're not turned off to it right at the beginning, you will find it a very interesting and rewarding course. So good luck, and we'll be seeing you soon.